All right, let's look at the homework 16.8, problem number 4. All right, so we're going to use the Stokes Theorem to evaluate this. So this is going to be, all right, by Stokes Theorem. So it's a double integral, right? So over this surface, right? And the curl of vector field F and dotted with d vector S, right? And this can be written as, right? So this is going to be a double integral, right? Then over the, let's see, it's going to be, so this is going to be inside the x squared plus y. So it's going to be over the unit disk. So I'm going to call that d, right? Then you have curl of f. Right, take the dot product with just the parameterization with respect to x cross parameterization with respect to y, partial derivative, dA. Alright, so let's compute the curl first. So curl of f is going to be, right, so vector I, vector j, vector k, right? Then the first, actually this is going to be partial with respect to x, partial derivative with respect to y, partial derivative with respect to z, and the first component is x squared y. Second component is 1/3 x cubed. And the third component is xy, right? So this is going to be, right, first component, right, partial of xy with respect to y would be x minus 0, right? Second component would be, that would be 0 minus the partial with respect to x, so it's going to be negative y. Right, last component is partial of this with respect to x would be x squared minus x squared. So it's actually 0. Right, that's kind of nice. All right, then we have to find the parameterization, and so hyperbolic parabola. So we can take, we can let r to be, so it depends on x and y, to be, we can just take x comma y comma, right, z is y squared minus x squared, right? Then we can take the r partial derivative with respect to x, cross product with the partial derivative with respect to y, right? So let's do that. So here's I and j and k. Right, partial with respect to x is going to be 1, 0, and the negative 2x. And partial with respect to y would be 0, 1, let's see, 2y, right? Right, so if you find the cross product, first component is 0 minus negative 2x, so it's going to be positive 2x. Right, second component is 0 minus 2y. Right, third component is simply just the 1. Right, so we have that. Alright, so this double integral is going to become, so it's a double integral over the unit disk. Alright, so you have, right, 2x, actually, sorry, it's a x, comma, negative y, comma, 0. Then we take the dot product with 2x and a minus 2y and a comma 1, right, dA over d, right? So if you compute that, you're going to get double integral over d, right? Multiply out, so you have a 2x squared plus another 2y squared. So I'm going to just put 2 outside, and I'm going to just write it this way, right? dA, right? Then we can evaluate this using polar coordinates. So this is going to be, right, so 2 is just a constant, so I'll kick it out. Then you have an integral, right? So remember that this is a unit disk, so radius goes from 0 to 1. And theta is going to go from 0 to 2 pi. Right, then you have a 2. 2 is already out. So r squared, x squared plus y squared would be r squared. Right, then dA is r dr d theta. So I'm going to actually write it as r cubed dr d theta. Right, so this is going to be, there's a 2. Right, so that we can separate this. So we have an integral of d theta from 0 to 2 pi. So it's going to go from, so theta from 0 to 2 pi times antiderivative of r cubed would be r to the 4th over 4 from 0 to 1. Right, so this is going to be 2 times, there's a 2 pi, and then multiply by 1 over 4, right? So we can cancel those guys, and then what you get is going to be simply pi, right? So let's check the answer, right? So answer is going to be pi, right? Let's check the answer. Submit for testing. All right, I came back and looks like we got this one correctly. All right, so let's look at the part B. Graph both the hyperbolic paraboloid and the cylinder. All right, so look at the cylinder. Radius is 1. All right, here it looks like a radius is only 1/2. Same here. So it's going to be the bottom 2. All right, then the surface is a hyperbolic paraboloid. So it's a y square has a positive sign. So in the y direction, it should be concave up. So you can see that, let's see, in the y direction, right, it looks like it's concave downward here. For this one, looks like concave upward in the y direction. So this should be the answer. All right, let's check the answer. Submit for testing. All right, I came back and looks like we got this one correctly. All right, so let's look at the part C. Find the parametric equations for C. Use them to graph C. All right, so parametric equation. All right, so we want the parametric equation for this curve right here. Right. So x and y, you have to go around on the unit circle. So it's probably let's see, parametric equation. So x is equal to, we can do cosine of, well, we can do probably theta, all right? And comma, y is going to be equal to sine of theta, right? And the z is going to be equal to, right? So since this is going to be, let's see, y squared minus x squared, so probably we can do y is sine, right? So sine squared of theta, right? And a minus cosine squared of theta. All right, so let's see if this takes the answer. So I'm going to go down and submit for testing. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.